Okay, so human capital growth. So the question for today is, what if not all labor is exactly the same, right? What if not all labor is exactly the same? So in the Solow model, we just have labor, right? We are assuming a worker is a worker is a worker is a worker. That obviously is not a great assumption. And so in a paper, a 1992 paper by Mankiw, Romer, and Wheel, which is basically the approach that your author uses in chapter 2, they basically ask, how does the Solow model fit the data? And their answer is pretty well. If you include a measure of human capital. Now, human capital is a fairly amorphous idea. Human capital is basically any sort of know-how that helps you become more productive. So it includes things like education, obviously, but it also includes things like experience. It includes things, quite simply, is know-how, right? So how you measure human capital is actually a really good question. And in fact, if this is a question that's interesting to you, there are definitely lots of papers that you can look at looking at different measures of human capital, right? So there are a lot of ways that you can measure human capital. Some of them are fairly technical, but here in this paper, they just measure human capital as education. Okay, we are just going to measure human capital as years of education. And so that is, of course, a potential critique of this article or this approach, is that we're taking a pretty simple measure of human capital. Having said that, I'm going to talk about some data a little bit later that suggests that no matter how you measure human capital, it is pretty strongly correlated with education. So just using education is not a horrible way of measuring human capital, right? I mean, you're really probably capturing the bulk of human capital when you just measure education. Okay, so now, how do we include human capital in our production function? Well, one of the, I think, probably the more clever things that Mankiw, Romer, and Wheel do here in this paper is really the way that they include human capital in their production function. They say, let the production function look like this. This is as before. The only difference here is that we have H instead of L. So once again, we have total fat, or we have productivity, and productivity is primarily increases the productivity of labor here, right? So A is primarily increasing the productivity of labor. Labor is human capital. And so once again, same model that we had before, A is growing at the rate of G. Now, here's what's new, and it has to do with H. What is H? Romer and Wheel say, let's assume H looks like this. Okay? That's psi. and psi is exogenous. And then we also have U. And U is also exogenous. Okay, what is U? U is number of years of education. And psi, you can think of as the return to education. So U is the number of years of education, and psi is the return to education. So in other words, what happens here? Notice that if psi is 0 or U is 0, then H is just equal to L. We just go back to the original Solow model, right? So if nobody has any education or there's no return to education, we're right back to the original Solow model. What we're saying here is that there's really two ways that you can improve labor. You can improve it by increasing the return to education, or you can spend more time in education. Why do we take this to the exponential power? Well, think about this. What this means is if you take the logs and then differentiate with respect to U, what do you get? You get, sorry, I shouldn't write this. You get that the change in H with respect to U is equal to psi. Okay? In other words, to put this into words, if you increase U by 1, then H increases by psi %. So 1 year spent on education increases human capital by psi %. That's the way you can interpret this. And so why have Mankiw and Romer and Wheel chosen to kind of model education this way? They've done this because there are a big group of studies, empirical studies. And one of the interesting things about these empirical studies is it's remarkable the consistency across empirical studies. Empirical studies have pretty consistently shown that 1 year of education increases wages by 10%. This is a pretty strong result across the empirical literature. Once again, if you're interested in these kind of studies, we can help find you some of them, right? But this is kind of a consistent result in the empirical literature, that 1 year's worth of education increases your wages by about 10%. So this should make you feel better about studying, right? I mean, why are we here? Because what's the value of a 4-year education? About a 40% increase in your salary, right? That's significant, right? That's significant. And so these studies suggest that, yes, there are very strong returns to education, at least in developed countries, right? There's very strong returns to education. And so what this means is that we will typically assume that psi is equal to 0.1. Okay, because that's really what the empirical literature is telling us. That 1 year's worth of education is worth about 10% increase in your human capital and in your wages. Now, I want us to note here, how fast does H.H grow over time? It grows by the rate of population growth. Okay, so human capital over time grows at the rate of population. However, an increase in U gives a one-time in H, right? So over the long term, how fast does human capital grow? At the rate of population. But an increase in education gives a one-time increase in human capital, right? In other words here, what we're going to find is that education impacts income levels, but not long-run growth, right? Not long-run growth. It's still going to be true in this model that how fast does output grow in the long run? G. Right? That's still going to be the conclusion. Okay, this seems a little weird until you think about it. But really, can a country grow by increasing their education forever? Probably not, because what's the limit on getting education? We have finite lives, right? We have finite lives. So if we look here in the U.S., you know, there is a theoretical limit to how much time you can spend in education during your life, right? So if we look across countries, when they have an increase in the average amount of education, it's not because, you know, in a rich country, it's not because people are spending more time in school. It's because more people are reaching graduation rates, right? Does that make sense? So in other words, what this model is really recognizing is that it's not really growth in education that's going to be driving long-run growth, but it is going to be driving differences in income levels, right? It is going to be driving differences in income levels. Let me add one other thing here to note. In our model, human capital does not impact A, and it does not impact G. So in other words, having more human capital doesn't make you more innovative. It doesn't increase technology directly. And you might say, shouldn't it? And the answer is, yeah, probably, right? In fact, this will be what we talk about on Monday, right? Because I do think that's a limitation of this model, is that in the real world, almost certainly having more education is also going to impact your ability to innovate. And so, but that's not something that's included in this model, right? That's not something that's included in this model. So in this model, human capital is kind of incorporated in a fairly limited way. It just increases your income levels, but it doesn't necessarily make you grow faster. Okay. All right, that's the intuition. The rest of the model is the same. And so I'm just really going to kind of talk through this very quickly, because honestly, really all that we've done is we've added this to the model, right? That's really all that we've done here, is we've just added this constant to the model. In fact, let's define little h. As this, okay? Little h is capital H divided by L. It's per capita human capital. That's really what we've added to the model. And notice that this is, in our model, exogenous. This is exogenous, right? Because psi is exogenous and u is exogenous. This is really just an exogenous variable that we've added to the model. So what does our production function look like? It looks pretty much like it did before. It looks like that. The only difference from what we found today and what we found on, was it Tuesday, is that now we have H in there. And our capital evolution equation, once again, looks exactly the same. Looks exactly the same. The only thing that is different here, I'll just highlight that, is that we have this H in here now. We have this exogenous factor that allows us to say that when a country has more education, it's more productive. So that along the balanced growth path, and here I'm going to skip a lot of algebra, not a lot of algebra, some algebra. What you can show is that when this is equal to 0, when k tilde dot is equal to 0, then with a little bit of work, you can show that this is what the balanced growth path level of per capita output is. So once again, this is exactly what we found before. This is exactly what we found before. What's the difference now? There's just this H in here. Remembering that H is just based on what your education rate is and what your return to education is. So just to be clear, Mankiw, Romer, and Wheel have done the simplest addition to the Solow model, right? They've actually changed the Solow model in the smallest way possible. They've just added a constant. And what is that constant? That constant is based on how much education you have and what's the return to education. Okay? So they've changed the model in the most minimum way that they can to allow the model now to incorporate differences in education across countries. Okay? So now, what makes a country rich? Just like before, they have high S, they have low N, they have high G and high A. And now there's a new thing that makes a rich country rich. High U and high H. We've just added another factor that makes rich countries rich. Okay? Just grab my pen, sorry. Okay, So that's the model. That's the model, right? Once again, kind of the simplest variant of the Solow model that we could come up with, right? The simplest variant of the Solow model that we could come up with that incorporates some measure of human capital. So now the next question is really an empirical one. How does this simple model fit the data? Okay, how does this simple model fit the data? Okay, so what Romer, Leal, and Mankiw do here, sorry, didn't skip up. What they do here is actually a technique that we will see a number of other papers use. And they say, let's express everything relative to the US. So we're going to define a new variable, y hat, right? And y hat is just going to be y star in country A divided by per capita output in the US. So whenever you see a hat here, what we're really saying is we're expressing it relative to the US. Relative to the US. So if this is less than 1, then it's poorer than the US. And it's greater than 1, you're richer than the US. Most countries are poorer than the US, right? So basically, y hat for most countries is going to be something between 0 and 1. Thus, if we go back to that equation that I derived up here, if we go back to this equation that looks at what should per capita output be along the balanced growth path, we could think about y hat star for country A as just being the differences in A between this country and the US, the differences in H between this country and the US, the differences in S between this country and the US, the differences in N and G and delta between this country and the US, and then alpha and 1 minus alpha. So here we are trying to figure out, using this model to predict how rich country A should be relative to the US. If we can get this data, we can predict how rich this country should be relative to the US. Now, here's the thing. Can we observe all the things here that we need in this formula? Not really. So, for the things that we can't observe, we're just going to assume that they're the same across countries. Okay? So in other words, let's assume that alpha is equal to 1/3 for everyone. We're going to take this out of the explanation of why some countries are rich and some countries are poor. Let's assume that psi is equal to 0.1 for everyone. Because we do not have data on what the return to education is for every single country. We have it for the US and some developed countries, but we don't have it for every single country. So let's just assume it's the same across countries. Let's assume that G is 0.025 for everyone. Why? Because we can't observe the rate of technology growth. This is the one you should be thinking, really? We'll come back and talk about that. This is probably not a good assumption, but we're going to start with it, see where we end up. Let's assume that delta is equal to 0.45 for, or I'm sorry, 0.5 for everybody. And then finally, let's assume that A hat is equal to 1. Meaning everyone has the same A as the US. Good assumption? No. As we're going to see, it's not. But we're going to start with it, all right, and see how far we can get. So what we're going to do is then we're going to use this model to predict what y hat should be and match against actual y hat in the data. And this is figure 3.1 in your book. Okay. So let me show you that figure here. Okay. And here we have it. What do we see here? Okay, the horizontal axis is the actual data, your actual y hat. I don't know why they don't express it like that in this table, but this is the actual y hat, okay? The horizontal is what is predicted for y hat based on our model. If predicted is the same as actual, everything should be falling along a 45-degree line. Okay, so if our model was exactly right, every single country would fall along this 45-degree line. In fact, what are we observing? Is every country falling on this 45-degree line? No, only rich countries are. All right, this model does a very good job of predicting rich countries. It does not do a very good job of predicting poor countries. Anybody have any guesses why? Chase.
It could have something to do with the fact that we're assuming the same technological ability as the US, or as the US, which rich countries should have, but poor countries might not.
Exactly, exactly. Notice here how we're over predicting for all the poor countries, right? We're over predicting for all the poor countries. Why? Because they obviously don't have the same A as the United States does. And so this Solow model actually does a very good job of predicting rich countries, but it does not do such a good job of predicting poor countries, right? To put this another way, Your book says it, well, listen, instead of just from the data, look at what the predicted A should be across countries. So if we, let me back up here. If we use that formula and said our model A has to adjust so that our model perfectly predicts output, okay? So if we said A adjusts so that our model perfectly predicts output, what is that A? And what we can see here, not surprisingly, as A tends to be very high in rich countries and it tends to be very low in poor countries. Okay, I mean, that is not a surprising idea. That's pretty intuitive, right? That's still the thing that this model is missing. It does fit the model and fit the data pretty well, but the problem is without any direct measure of A, we still have a hard time fitting the data because A is so important. In other words, it gets back to this problem that in many ways, A is a measure of our ignorance, right? It's a measure of our ignorance. It's a measure of what we cannot directly observe. And so the fact that we cannot directly observe it, we know that it's important. We know that there's important things in there, but we have a hard time directly observing it, right? We have a hard time directly observing it. Another way to see how important A is to do this little calculation. Okay. Let's do the same trick with Y hat, but this time, let's just look at the 5 richest countries and the 5 poorest countries, okay? Shoot, I didn't leave a lot of space here. I can squeeze this all in. Can you read that? I did a very bad job of spacing out my writing here. So this is just using that formula before, but this time the Y hat is not all countries. It's just, let's compare the 5 richest countries to the 5 poorest countries. I shouldn't use 5, forget that. Don't compare it exactly to Y hat. So let's just look at data and compare what's true in the 5 richest countries to what's true in the 5 poorest countries. So if we look at data comparing the 5 richest countries, what is this in the real world? This is 70. Meaning the 5 richest countries in the world have per capita income levels that are 70 times the 5 poorest countries. What if we look at the ratio of H, right, which is basically based on differences in education? 2. So the rich world definitely has more education, about twice as much. They spend about twice as much on education. What about all of these things? 2. So in other words, of this big difference in Y, a little bit of it can be explained by differences in H. A little bit can be explained by differences in N and differences in S, right? Which are the things that we're allowing to be different here. So what is X? Well, 70 divided by 4 is about 14. So in other words, what's the most important in explaining the income differences between rich countries and poor countries? A, right? The vast majority, or to put this another way, about 75% 75% of total variation in per capita income between rich and poor countries is because of differences in A. And only 25 because of differences in U and N and S. All right, so in other words, we just keep on coming up with the same conclusion, right? Over and over again, is that it's really A. A is the biggest determinant of variation in income across countries. And it's the biggest determinant of growth across countries. So we are going to have a lot more to say about A. We can't just treat it as exogenous because it's too important. We have to begin to think more critically about what A is and where it comes from. And that's what we're going to begin tomorrow and then in earnest on Monday and Tuesday, right? Is to think about A much more carefully, right? What in fact is determining differences in A across countries. So that's really where we're going to determine where we're going to go. One last thing here, and we're going to take a break. But is there conditional convergence? Is conditional convergence happening across the world? Remember, we talked about this yesterday. It's countries with the same balanced growth paths. Should be seeing their incomes getting closer together. So there is a way here in the model that we can actually do that. One way that we can look at whether conditional or convergence is coming here is to calculate calculate what output should be in each country relative to what its actually is. And then what should be true if this is less than 1? Or if this is greater than 1? Yeah, Chase.
If it's less than 1, should it be growing faster?
Yeah, well, okay, hold on. I'm sorry. I screwed this up. Damn it. I'm sorry about this. Your book actually calculates the ratio in the opposite way. I wrote this backwards. Sorry about that. Damn it. Okay. They actually calculate the ratio of actual to predicted. And I wrote predicted to actual. Sorry about that. So let's try this again. What if actual output is below predicted? And remember, think about this predicted as the balanced growth path, right? Think about predicted output as the balanced growth path. So if output is less than predicted, then this ratio will be less than 1. So Chase, what did you say? If this ratio is less than 1, then a country should
Be growing faster.
grow faster. And if this ratio is greater than 1, they should grow slower. And so this is what your author looks at in figure 3.6. Nope, 3.8, sorry, 3.8. So the horizontal axis is looking at that ratio I talked about, the ratio of the ratio of actual to predicted. I'll get that straight. The ratio of actual to predicted is on the horizontal axis. So notice here, like 1, a country that's at 1 is right at their balanced growth path. A country that's less than 1 is below their balanced growth path, according to this model, and a country that's above 1 is above their balanced growth path, according to this model. What do we see? Well, the relationship is not perfect, but you do see this negative relationship, right? That's predicted. That countries that are below 1 do tend to grow faster, and countries that are above 1 do tend to grow slower. So this is some mixed evidence. I wouldn't say this is particularly strong, but this is some evidence that yes, conditional convergence is in fact happening, right? And so, in other words, this stuff that we're teaching you, yeah, it is out there in the data, right? It is there. Now, it's not the only thing that's going on, right? I mean, once again, everything isn't falling on a perfect line, right? So there's a lot of noise in this data. Probably a lot of that noise is, once again, there's a lot of things that we cannot directly measure very well, right? Our data is limited. But given the limited data that we have, yeah, I mean, there does appear to be some conditional convergence. And that's good, because that's obviously a very important part of the Solow model, right? If we weren't observing conditional convergence, then we would be we'd be worried about using the Solow model as the basis for how we think about growth. But I think this is a small check in favor of the Solow model. Okay, why don't we take a break here? All right, this is a good time to take a break. We've done a lot of the heavy lifting for today. After break, I want to come back and talk about really is human capital the same thing as education? And what does the data say? Does the data suggest that when countries invest more in education, they grow faster? So we'll kind of talk about those. We'll talk about a couple of random studies. So let's take a little bit of a longer break. Feels like we worked really hard. So how about 10:05, right? We'll come back at 10:05, give it a full 10-minute break, and then we'll talk about the data on education and growth. All right, see you in a couple minutes. I'll leave this up and running if anybody wants to chit chat. Hey, everyone. Okay, so we've kind of got it through I would say, the more theoretical part of today's lecture. Let's kind of talk more about, I guess, the empirical part, or just kind of the more pragmatic, broader perspective on this question about human capital and its relationship to growth. The first question we really should ask ourselves, and I alluded to this earlier, is this question of, is human capital equal to education? Right? Is human capital the same thing as education? Right? No. And in fact, you can include other things to empirically that would also contribute to human capital. Things such as life expectancy, right? Because obviously longer lived people are going to be able to create more experience and more know-how that they can bring to their jobs. Infant mortality, right? If you lose a lot of your population in those early years, you're essentially losing a lot of human capital. Many studies have looked at things such as stunted growth. So what percent of your population is essentially underfed and has stunted growth? We know that stunted growth is associated with lower cognitive ability, right? And so obviously not having healthy diets is going to impact your ability to think and get a good education. Obviously, years of education many studies have looked at things such as scores on tests, including something called the PISA test. I'm completely blanking on what PISA is a acronym for. But PISA is basically an international test that's administered to high school students across the globe. And so it's essentially a way of looking at educational quality using very similar tests across the globe. And then, of course, years of education, which is what we have been using here when we were talking about the Mankiw, Romer, and Wheel article. So just to pick one study, okay, so just to identify one study here. Here's a study that I actually referred to in the, learned about in the Economist magazine. So this is a study that's looking at actual measures of human capital. And in fact, they create an indice, meaning a single measure that incorporates all of the things I just talked about: life expectancy, infant mortality, stunted growth, scores on the PISA test, years of education. And here's just a short little summary of this. But this is looking at the index score relative to your, am I confusing this? Oh yeah, right, I'm sorry. This is looking at two different measures, right? One is the World Bank, which primarily emphasizes education. And then here's this other score that incorporates all of the things that we see that I've just talked about here. You notice that there's a strong correlation between these two things, right? So there is a very strong correlation between years of education and these kind of indexed measures of human capital. And so can you use broader measures of human capital? You can. The research suggests, though, that it's not going to add a lot of predictive power to your data, right? In fact, what the data really shows is, of these things that we talked about here, let the screen share come back, which are the most important? These last two, and particularly years of education. So years of education are probably the single best measure of human capital, which is not completely surprising. Scores on tests such as these PISA tests, though, also do very well in terms of matching, being closely correlated with other measures of human capital. Okay, so while it's not perfect, we can think about human capital as basically education, roughly education, right? That's probably a pretty good first proxy for it. So then the question is, does education lead to more growth? Does having more education lead to more growth? This was a focus of development policy in the 60s and 70s, okay? This idea that one of the ways that we can help poor countries get richer is to help them get more of their population in school. So one of the things that most people don't know about, since 1990, we have about 99% of African students fully enrolled in primary school. That was in many ways the outcome of this focus on education of the 60s and 70s. If someone tells you that African countries are poor because kids don't go to school, that is wrong, right? Or let me put it another way. If somebody says, well, part of what makes sub-Saharan African poor is that a lot of kids can't go to school. No, that's not right, right? That about 99% of African students are fully enrolled in primary school who are of the correct age. And that's been true since about 1990. So now we have basically 2.5 generations of Africans who have had the opportunity to fully enroll in primary school, all right? Has this led to a boom in growth? The answer is obviously no. Education in and of itself has not significantly increased growth. Right? It has not significantly increased growth. Let me share with you a little bit of data on this, right? Sorry, skipping through some things. So here, just to kind of reemphasize what I said before, you can see some of the dramatic increases in the years of schooling across developing countries, and it's also happened in advanced countries, including the United States. But the increase in the number of years of schooling has gone up significantly, right? The percent of the population that has completed a primary education has gone up significantly in developing countries. That have completed a secondary education has gone up significantly, right? That have completed higher education has gone up significantly, though this number is still pretty low in most developing countries. But once again, when we look at the data, what we see is that in many countries, it just hasn't mattered in terms of growth. So this is looking at some African countries. The dark lines are growth in years of schooling, and the gray lines are growth of per capita GDP, right? And we see that some countries have had significant increases in the amount of schooling and have actually had negative GDP growth, right? Ghana, Madagascar, Senegal, right? There are some success stories. Botswana, Lesotho. I'll have more to say about Botswana later. I'll actually talk about Botswana as a case study for us next week. I lived there for a while, and so I'm quite familiar with what goes on in Botswana. But yeah, we just have not consistently seen this relationship between putting more kids in school and seeing growth. And so that's really a good question. Why? Why hasn't more education led to more growth? And let me put it another way. Maybe the better way to phrase this question is, why would people think that education alone would lead to growth? Right? I mean, it is, I would say, from policymakers, a bit of magical thinking to think that all you have to do is put a chair in a schoolroom and tell a kid that they can sit in it, and that's going to lead to growth, right? It just isn't that simple. It just is not that simple. Saying that kids have the ability to go to primary school is not enough to generate growth, right? And so I think it's pretty easy when you think about it a little bit more to pick apart this argument as to why just simply putting a chair in a schoolroom is not going to be enough to increase growth. The first thing is, one of the things we know about education is you need the complementary inputs. You need capital. You need technology. And very importantly, you need other educated people. One of the ways that human capital becomes valuable is when you interact it with other human capital, right? We'll talk about this a little bit more when we talk about technology, but I think one of the biggest fallacies, and in some sense this is an American fallacy, because in America we have this idea of kind of like the lone genius or the lone entrepreneur, right? The super superstar who kind of builds a company by themselves or comes up with this great idea by themselves. That's complete bullshit, right? I mean, there is nobody that comes up with new technologies or new businesses by themselves, right? Human capital is really only valuable when it interacts with other human capital, right? In other words, as we're going to talk about, most innovation is networked, right? And what is a network? A network is other technology and other capital and other educated people. So human capital is most valuable when it's part of a network. And so when you don't think about this, this is the problem of a poverty trap. Why would you invest in an education if you're only going to live around uneducated people? The poverty trap idea is not just a trap for people living in sub-Saharan Africa. It's a trap for people living in poor areas of any country, right? So to bring this closer to home for those of us who are Americans, let's say that you grow up in a small coal mining town in West Virginia, and you make a decision that you want to spend your life living in this small town in West Virginia. What's your incentive to get a college education? Not much, because what are you going to do with that college education in a small town in West Virginia? Not much, right? Its ability to increase your productivity and your wages is not going to be enough to offset the cost of it. And so why should I go, right? That is the essence of a poverty trap. If you decide that you are going to live around other poor people, any education you get is going to be less valuable. So how do you get out of a poverty trap? Well, for many people, this is the story. Oh, sorry, I didn't mean to do that. This is the story of brain drain. And brain drain is about the migration of educated people to escape poverty traps. And to network, to get in these high quality networks. This goes back to one of the things we talked about when we talked about the basic facts of growth. This is one of the reasons why location matters so much, right? What's the return to getting an education in a poor country? Not very high. How do you increase the return to that education? You have to move, right? And so what do we see? Places that have more educated people attract more educated people. And places that have less educated people have a hard time keeping the educated people that they have. This then creates a lot of externalities. There's a study I saw recently that was looking at Ethiopia in particular, and looking at who got the benefits of increased schooling in Ethiopia during the 1970s, right? So now that's 50 years ago. So they've been able to follow these people who basically took place in this education boom in Ethiopia. And what this study found, which really shouldn't be too surprising, is that half of the benefits of the increase in schooling accrued to other people. Not the person who got more schooling, the people around them, right? Meaning their family members, their community, the country. So there are big positive externalities, right? Positive externalities and negative externalities. right? This is a story about externalities. When you are an educated person and you can get around other educated persons, they give you positive externalities and you give them positive externalities. But when you're stuck in a poverty trap, it becomes really a question of them giving you negative externalities and you giving them negative externalities, right? And so brain drain is a real problem. Now, having said that, I am not saying that people should not be allowed to migrate, right? um, I'm fairly certain, and in fact, there's a few articles on this question. But really, many countries, some research has shown that brain drain over the long term is actually beneficial for the country that loses people. And the reason is a couple of fold. First off, everybody who gets an education, not all of them migrate, right? So some people will invest in an education and they end up not migrating. And so they stay behind and they can begin to create those positive externalities. The other beneficial thing about brain drain is that oftentimes it's not permanent, that people will leave for a while, but eventually they'll come back home. And so for our Chinese friends in this class, this is a phenomenon that you're familiar with, right? This is one of the things that's been happening in China here over the last 20 or 30 years, is if you looked 30 years ago, right, what you saw is that a lot of Chinese students who came to the US to study stayed in the US. Now what's happening today? A lot of those people who stayed in the US for 20 or 30 years have now gone back to China. And then you're also seeing a lot of Chinese students who come to the US to study and go back now, not after 20 or 30 years, but go back immediately. Now, sometimes that's because of bullshit immigration policy, right? But sometimes it's because they actually want to go back, right? There's much better opportunities now to use an education in China than there were 30 or 40 years ago. You see the same thing in India, right? Where India suffered significant brain drain in the 70s and 80s, but then now a lot of those people are going back to live in India, right? And so brain drain can still be beneficial for the country for which education is draining from. But anyway, this is all to say that, you just can't expect to educate a couple of kids and that's going to lead to growth. You need to have the other things too, right? You need to have the other things. I think there's a couple of other reasons to really be skeptical about this idea that education in itself is going to lead to growth. The second is, one of the things we know is that the quality of schooling varies widely. To say that a kid can go to school does not mean that they're learning anything. If you look at the student to teacher ratio, in rich countries, this is 16. What about in sub-Saharan Africa? 48. 3 times as many kids in any school. Obviously, that's going to have a pretty important impact on the quality of education. In sub-Saharan Africa, many teachers don't have a secondary education. Right? They don't have a high school education. That's not knocking them. That's just really a stage of development. I don't know why kind of a stupid thing to talk about, but I got some young kids, and so we were reading Little House on the Prairie, which I don't know if you're all familiar with Little House on the Prairie, but it's the story of Laura Ingalls Wilder, who lived in Wisconsin and Iowa in the 1800s, and basically the story of her life. And my kids were amazed that Laura Ingalls Wilder went to school until she was 14 and she was a good student. And what did she do when she was 15? She became a teacher. And that's the way things worked, right? Oh, you're a good student? Sure, teach, right? And so that's not to say that some of these people aren't good teachers, but it also tells you the limits to the quality of the education that's really available in some of these schools. The other thing is we know that there are low teacher salaries. And so what do you get with that is you get low teacher attendance and low teacher work effort. And this has been documented in many studies that show that in places such as rural India, up to 1/3 to 1/2 of all teachers don't show up on a daily basis. And the reason is their salary is so low that they just kind of show up when they want, right? And if they get fired, well, who cares, right? Particularly in rural India, it's kind of hard to kind of monitor some of these people. In fact, one study that I'm familiar with, one of the things that they did is they just invested in cameras and put them into these rural schools to actually see when teachers showed up. And it actually significantly improved teacher attendance and test scores over time. So yeah, there are big differences in teacher quality. If show you a little bit of data on this. This is looking at enrollment in secondary education in primary public schools relative to teacher salaries, right? And so you'll see, in countries that have high enrollment, they also tend to pay high teacher salaries. And so what's this telling us? This is telling us that a lot of kids don't go to school because they simply don't have good teachers. The teaching, the quality of the education is not enough to get them to go to school, right? And so, you look down here in Brazil, where they have 10%, 20% secondary school enrollment, at least in 1995, and you look at their primary school teachers, they weren't being paid very much. Related to this is an interesting article. Oops. Let's try this again. Here's an interesting article found in The Economist not too long ago. Where migrants go to school is more important than the way they came from, right? This is looking basically at students who took the PISA test, the PISA test, right? And then looking at what's the biggest predictor of how well they did on the PISA test. And not surprisingly, it's the country that they migrated to that was more important than the country that they migrated from. Why? Because in almost every case, migrants were moving to countries with better education than worse education, right? And so this is just another example of why location matters. Location matters not just because you can go to school, but because some schools are better, right? And so oftentimes migrants aren't just migrating for the income, they're also migrating for the opportunity to send their kids to better schools. And that's not a shocking conclusion, right? I think that's not, you don't need me to tell you that, right? You're all familiar with, many of you might be children of migrants or have migrants in your family or whatever. You know that a lot of times migration is driven almost as much by quality of education as it is by differences in income. It's not just teachers that don't show up, it's the students themselves, right? This is the problem of child labor. Many kids can't go to school because they really do have to work. If you're living close to subsistence levels of income, having kids working is not an option, it's really a requirement. Here's the good news. Kids are really bad workers, right? I know this. They're very bad workers. And as a result, if you can increase family income by even a little bit, it will significantly reduce the rates of child labor. And so one of the more effective development programs that have been put into place here over the last 20 or 30 years is, and there's many variants of this, particularly in Latin America. I spelled this wrong. But there's the Bolsa program in Brazil. And what the Bolsa program is that families can get a small monthly stipend if their kids go to school and they get vaccinated. Right? Not much is asked. And when I say a small monthly stipend, this is about $20 a month. And what Brazil's been able to do is through programs like Bolsa, really get enrollment rates from where they were in the 90s down to 19%, all the way up to 80% and more in some parts of Brazil. So these kind of programs have been very, very successful, right? And I think many economists have pointed to these kind of, what they are, for those of you who follow politics, it's close to a universal income thing, right? Universal income is something that's being talked about in the US, right? Should we guarantee families a certain amount of money per month? That's what they're basically doing in Brazil. Mexico has another version of this. I think it's called Progressa program, but it's very similar in idea. We're going to give you a stipend. You just make sure your kids get vaccinated and they go to school. If you do that, you get the money, right? And that works for many families because poor families love their kids as much as rich families love their kids, right? It's not like poor families want their kids to work. It's a question of they need to work. And so even giving a little bit of money to get them above subsistence is enough to kind of free them from the trap of child labor and to be able to send their kids to school. So this is one of the reasons, these are, I would say, the three big reasons why, why education has not led to a growth boom across the world, right? Let's talk about, just in conclusion here, about the US a little bit. I've talked about education and I've primarily focused on poor countries. What about education in the US? I don't think there's really much that you can argue about this. The US educational system at the primary and secondary level is not good. Of course, in higher education, pretty clearly the best in the world. But in terms of secondary education, not really that great. Let me just show you show you a little bit of data on this. If I can find it. Sorry, I lumped everything in this one PDF and it kind of copied strange. Okay, let me show you this. This is a little hard to read. I'm sorry about that. But you know, basically the takeaway from this is if you see where the United States is, it's really at the bottom of rich countries in terms of how our students score on these PISA tests, which basically measure basic math, reading, and science comprehension. So among rich countries, we are really at the bottom of the pack, right? We're really at the bottom of the pack. And so there's been a lot of talk about why the US does so poorly on these primary and secondary. So let me talk about that. First off, there are people, and I think there is an element of truth to this. There are people who are saying the fact that the US does very poorly on math, reading, and science doesn't mean that the US educational system is not a good educational system. And I think there is an element of truth to that, right? For those of you who have studied in the US and have also studied in other countries, you'll notice that there's something that is distinctly American about our educational system. And that is, we tend to encourage people to think creatively. We tend to encourage people to think individualistically. And so I think there is something to the US educational system about creative thinking and thinking outside of the box and being entrepreneurial in your thinking. That is a very good thing about the US educational system. For instance, just talking about China. Let's talk about China for a second. So when I go to China every couple of years, we spend a lot of time in Shanghai. Shanghai is the school system that ranks #1 in the world in these PISA tests. Okay, so if you actually look at which schools in the world score highest on these PISA tests, it's Shanghai. And so what happens when you talk to parents who live in Shanghai about the Shanghai school system? What do they say? It sucks. It's horrible. It's horrible. It's horrible. Why? Because what do the Shanghai schools do? Teach to score well on the tests, right? So all they do is teach to score well on the tests. So yes, these kids are well trained in doing basic math and they understand reading and science is designed for the test. But what happens when you release them out to the real world? Parents will tell you that their kids are not particularly well trained, right? And so their kids are not well trained, for instance, to go to a US institution where they're expected to be more well versed in the liberal arts, right? And to think creatively and to think interdisciplinarily. So, right, listen, a good school system in many ways is in the eyes of the beholder, right? I guess that's what I'm trying to say. So it is difficult to say what's a good school system and what's not. I will say, though, that there have been a lot of studies that kind of look at what does make for the best school systems. And what the research has shown is that there's really 3 things that we tend to see in the best school systems in the world. One is they tend to get the best teachers. And that sounds obvious, but it's hard. This is no insult to education majors. It's just a fact. But in the US, we tend to recruit from the bottom 1/3 of graduating classes. for our teachers. If you look at, for instance, Scandinavia, which are largely regarded by everybody as being the best school systems in the world, they tend to recruit the top 10%. In other words, teaching in Scandinavia at the university has same quality teachers as it does in their high schools and their elementary schools, right? So, you know, when I say teachers here, when it comes to college teachers, yeah, we are absolutely recruiting from the top 1%, 2%, 3%, right? We are recruiting the best and the best to teach in our higher education programs. But then we do not do that here in the US to teach in our primary and secondary. Once again, I'm not ripping on teachers, right? Because we know there's some excellent teachers. But in general, we don't recruit the best of the best. How in the world does Scandinavia do this? A lot of it, quite honestly, is prestige. In Scandinavia, being a college professor has about the same amount of prestige as being a high school teacher. That's not the case in the US, right? We tend to view our elementary and primary school teachers as not as a prestigious job. And then, of course, some of this comes down to pay. That Scandinavian schools pay their teachers a lot. And I won't say a lot more, but they do pay them more. So if we were better, if we wanted to have a better school system, we would get the best teachers. More training. The best school systems train teachers year-round. And that's something we don't do here in the US. In the US, we have this strange system where we don't teach in the summer. And teachers kind of expect to be off in the summer. Where in many countries, they really train year-round. And this is probably something that the US could be investing more in. And then the third thing that we see about schools that have the best quality teachers is there is a lot of early intervention when it comes to teaching. The best school systems do very good jobs of trying to prevent children from falling behind and doing things such as intensive tutoring. In the US, we tend to spend more on high school students than we do elementary students. That's probably backwards. We should be spending more money on young kids than older kids. Because oftentimes when kids get off to bad starts, they do not recover. And so, for instance, in Scandinavia, they do intensive tutoring for kids who are not matching grade level, right, or falling behind in school. One thing, though, you'll notice here, these are I think what the studies have suggested makes for good school systems. The best teachers, more training, intervening early. Something, though, that has not always worked is more money. So strangely enough, more money in and of itself is not going to create a better school system for you. We know that in the United States. Some of our worst school systems spend the most per student, right? I'm thinking here about Chicago schools, many of you from Chicago, right? Chicago has one of the highest rates of spending per student in the country, and also has one of the worst school systems, right, by most measures. if you look at the data, you actually see this across countries too. Look at this graph here. This is looking at how a country scores on the PISA test, the vertical line, versus how much they spend per pupil. So notice, if you're not spending very much on students, it does hurt your test scores. But then there's kind of a point where you're spending about $50,000 a student, right, at purchasing power parity, where the benefits of spending more on students really start to level out. And so that's not to say that more spending hurts, but more spending alone is not going to make you a better school system. You have to figure out what you're going to spend your money on. And I think, you know, a lot of these studies suggest that you should be spending your money on getting the best teachers, early intervention, and teacher training. Those are the things that really seem to provide benefits. And unfortunately for the US, those are three things that we just don't do very well. We simply don't attract the best teachers in general. We don't spend a lot of money on training. And we are not spending enough money on early intervention. So that's kind of my knowledge of the education literature, right? So I am not an education professor. I would not consider myself to be an expert, but that's kind of what I've learned by reading some of the literature on education. And so, you know, hopefully that informs any future discussions you get into about what's going on with the American educational system. All right, we actually got, I'm sorry for running a little bit over here, but we really got through all the new material that I wanted to cover today. So this afternoon, we're just going to meet with Megan. I think she's going to have maybe about half an hour or 45 minutes for us. And then that will be all of class this afternoon. So we'll have a pretty short class. So anyway, we'll meet you back here at 12:30. Be prepared to learn a little bit about working in the library, okay? All right, have a good lunch.